Hello dear all lovely students, welcome here once again, and this is the chemistry assignment 8-week SSC batch 2021. I'm very sorry to say that each and every week I try to give the solution of the assignment, very quick response within the short time, but this week I was personally sick and physically, so it was not compiled with the solution, so I gave very quickly the first part of the physics solution also, but second part today I published. That means many of the days intervals. Now I recovered myself. Thank you very much for connecting and having patience on there, and let's go to solution. This chemistry assignment is very simple if you understand. If you don't understand, it will be very tough one. I don't go through reading about what is asking for. We know about several times. We see here what type of compound to take on there, to take over accordingly. Now better to go through on there specifically. They have no chance to got on there to read up everything. Just go through directly the solution. A number. Here asking two compound to take. One is the methane and one is the sodium chloride. This is the assignment. First of all, the question number A asking for duet rule and octet rule to explain in case of these two elements. Very first time, okay. At first we will write in their duet rule. Duet rule, that means only the elements here. I just only an inert gas. Helium has two electron in its outer shell. If any elements that follows that can get the structure of helium, that element to follow duet rules. Done. Simple starting point. Who has, since we know about the helium here, 4 1s2 2s2 in its outer shell, 2 electron. So any elements want to get this structure, we can say they are also they followed the inert gas helium structure, or we can say they follow the duet rules. Simple. Okay. At first, duet rule and octet rule. Listen. Octet rules. If any other all the inert gas will have followed the octet rule. If any elements can get the structure of 8 electrons, 8 electron state in their outer shell, they will follow octet rule. I have written this one. In case of methane, since it is asking for in case of methane, and in case of sodium chloride, I will give you instruction. Sometimes some things according to the electron distribution you will write accordingly, so the answer will be clear. I write the basic strength and a starting point, then you will not, yes, you write this up to this one, but whatever the explanation in there, I will make you understand in this way. Suppose here carbon 6, 1s2, 2s2, 2p, 2. In its outer shell, 2s and 2p has 4 electron. Hydrogen 1, 1s, 1. So hydrogen will get or share 1 electron to get the structure of helium, and carbon need the 4 electron to get the octet rule. That means 8 electron state to form on there. So hydrogen only 1 electron in them, and carbon has 4 electrons in them. So one hydrogen cannot share with the 4 carbon outer shell electron and cannot get any structure on there. So carbon say, yes, 4 hydrogen come, I will share with you. Likely that means here hydrogen has 1 electron in its outer shell and exchange 1 electron to get the structure of helium. It is same in the lower part on there, what I have written on there. Yes, it is same, but it is not accepted. Why it is not accepted? Because 1 hydrogen cannot share with the 4 electron of the carbon here. They need the 4 electrons. So after then you will write in below. I have not a space on there, I write in there. So 4 hydrogen share electrons with the carbon and form methane. On the other hand, in case of sodium chloride, if we see sodium outer shell electron 1, 2p6, 3s1, you will write outer shell electron 1. They will release 1 electron, release 1 electron and get the structure of neon. Get the structure of neon. You can write in V. Okay, neon. On the other hand, chlorine, you will write the electron distribution of chlorine on the right. It is in the above part. Chlorine, in case of chlorine I will write directly 17, 1s2, 2s2, 2p5, 2p6, 3s2, 3p5 in its outer shell, 7 electron. So chlorine outer shell electron 7, chlorine receive 1 electron to get the octet rule, 1 electron, and after getting that one, to get the structure of argon. 17 plus 1, it would be the argon. So we explain according to the instruction. Here is the question: instruction of octet and duet rules to follow. Applicable both case, in case of both compound, if the student explain the duet rule and octet rule, they will get 4 out of 4. So already you got the 4. Next question we will go through. Then the methane. In case of methane, their compound formation, covalent compound formation, and their polarity to explain up here. Polarity. they asking for compound formation and their polarity clearly instructed here, how they will form the polarity, or we can explain about the polarity in case of methane. Let's go. Where is the question and instruction? How will you get the 4 marks out of 4 in there? Okay, let's go. I don't know where is the question. Okay, let's move on there to finding the B number question. Okay. Covalent compound to form B number. Methane. Forming covalent compound. Methane forming covalent compound. How? According to the electron distribution. According to electron distribution, carbon. We already know about 1s2, 2s2, 2p2. This is the normal state. Look at here. It is a normal state, but when it is the excited state, we can write here it is a normal state, normal, and it is the excited state. So 1s2, 2s2, 2px, 2py, 2pz, 222. So the maximum electron containing capacity in the p orbital is 222. So here 1, 1 and 0. 1s2, 2s2, okay. 2px, 2py, 2pz. Since the 2 electron, 2px1, 2py1, 2pz0. But overexcited state, excited state of carbon, same 6. 1s2, 2s1, 2px1, 2py1, 2pz1. This is the second shell. All the electrons are single. Now able to make sure the bonding formation with the hydrogen. Hydrogen on the other hand, we have seen on there the hydrogen 1s1. So it is needed to 4 hydrogen. That means 4 hydrogen share 4 electrons. 4 hydrogen share with 4 electrons. 4 electrons with carbon and make covalent bond. Simple. You can write added something that what in the accelerated state we can say the 4 lone pair electron. Now carbon is ready to make sure the bond formation with the hydrogen, or likely that way. Which way we can now go through on there the chart and figure accordingly. Okay, fine. The diagrammatic after then you will write. I will erase because the board space is not enough here. Okay, then after. Okay, listen, the carbon 2 and outer shell 4 electron in there. Okay, carbon plus hydrogen is only 1 electron in its outer shell, but only carbon 4 and 1 electron is not possible for sharing. So how many electron will be connected in there? Listen, hydrogen, once again hydrogen, that means 4 hydrogen when come close together to make sure the electron sharing. On that time it is possible only. In the question clearly asking for, clearly say that show the diagram accordingly. Everyone explain, but no diagram, it is impossible to give the proper solution on there. Next one, this is the carbon 2 electron and the 4 electrons we know about their outer shell. And listen, the carbon, hydrogen, this hydrogen 1 electron, hydrogen, this hydrogen 1 electron share, they share, since the 4 lone pair electron we have found on there. So hydrogen, arrow sign will be, you can use on there. This is the structure, structurally to mention on there. So what happened in there, after then you will write arrow sign in below on there. So this is the carbon in the center, and 2 electron make a bond. Keep it in your mind, 2 electron make a bond, likely to have 2 electron. Here is the hydrogen, here is the hydrogen. Actually the figure will be likely that way, quadrilateral shape. We can see hydrogen, the 4 straight on there. You can skip up this stage directly, you can go through on that way. Quadrilateral shape to find out accordingly after sharing the 4 electron of hydrogen and carbon together and form likely to the covalent bond by electron sharing. I think you understood this one. Now we will explain here the polarity in the B number question, the second part of the polarity. I think you understood this one. Polarity, okay, polarity, covalent compound in maximum case do not or don't dissolve in the solution or in the water. Maximum case. Exception also be there, sucrose, it is also covalent compound, glucose, they mix with the dissolve in the water. But maximum case, so that they don't dissolve in the water because they have no metallic positive ion that can attract the negative hydroxyl ion of water molecules. You can ask me, sir, hydrogen ion is the positive ion, it is not metallic ion, it is also a gas, but according to the nature they got the positive ion. Okay, so no positive ion in the methane, no positive ion in the methane molecules. Okay, likely to have, look at here, water, you know, H2O, water molecules, this way they will form or likely to have this one, partially plus, partial minus, likely to have this one. So the methane also, look at here, if we see on there methane on there, in there is no way to have any metal, there is no metal in there, if we make sure that dissolve in there, so it will be not attracted by any elements from here to there, so no chance of dissolving, dissolving. Normally you will write extend up in this way. Simply we can write accordingly here to the polarity, non-polar compound finally. So we can say methane is a non-polar compound. So this is the B number answer, simple. Number C. Now we will go through the C number, and I will suggest you to go through your book. Why I tell you? Because I have written something and you can collect knowledge from your, oh no, this one is where? Chemistry. Yes, just a couple of seconds. I'll just take your time. Okay, it would be on there. Page number 101. You can go through on there for better understanding of on there. Okay, no chance of dissolving since no positive ion are likely, that we can say. C number question. Now let's go to the assignment in the C number question. Same thing to explain in case of sodium chloride. Same thing to explain here. Where is the question? Yes, same thing. Same thing asking for their ionic bond form in case of the edible. Ionic bond in case of the salt. Okay, let's go to move on there. I will take it on my mobile charge is actually. Sorry for interruption of today's solution. Okay, now C number question. C number. Let's go to now about the C number question. Sodium chloride. Okay, fine. Compound formation, ionic compound formation we know about. Then the electron distribution. At first you will write the electron distribution of sodium chloride. Okay, sodium 11, 1s2, 2s2, 2p6, 3s1. Okay, look at here. Sodium release one electron, got sodium ion. That means the structure 1s2, 2s2, 2p6. Neon. Understand? Yes. You will write some line here. Sodium, whatever I have written in previous time. Sodium in its outer shell, one electron it will release to get the structure of neon and follow the octet rule and got the positive charge. Just two lines you will write in there. Then after chlorine 17, 1s2, 2s2, 2p6, 3s2, 3p5. 3p5 on there. Okay, chlorine receive one electron to get chloride ion. That means 1s2, 2s2, 2p6, 3s2, 3p6. That means they will get the structure of argon. You will write two lines. In case of chlorine, the outer shell electron number is 7 and chlorine receive one electron to get the chloride ion and get the structure of argon. Follow the octet rule. What I say? You can write. I think you write. You will be able to write in there. Same things. Outer shell electron they release to get sodium ion structure of neon inert gas. Outer shell electron need one electron they receive and get the structure of argon and follow the octet rule. And this way the reaction is going on there. And finally, the total reaction you will write on there. Total reaction. Sodium minus electron, sodium ion. Chlorine electron, chloride ion. total electron is turned off and cut off in there, sodium chloride, and we will get the sodium ion plus chloride ion. Simple. That means when sodium ion and chloride ion ionic form close and combine together, this way sodium chloride to form. Or if we break down sodium chloride, we will get the sodium ion and chloride ion. This way ionic compound form. Simple. But diagrammatic presentation is also left, likely that we have done in case of methane. That way the diagrammatic presentation, you can write on there diagrammatic presentation. Okay, fine. What is the diagrammatic presentation, how they form on there, we will go through on there. Okay, directly same thing it is given. You can get the knowledge from 95 number page on there. Okay, sodium outer shell electron 2 8 1 2 8 1 outer shell electron 1 1 sodium outer shell electron number 1. Listen, I tell you, sodium outer shell electron number 1 plus chlorine 2 8 8 7 sodium and chlorine to react together, but how they will form the bond on their chlorine, that means sodium release 1 electron sodium ion, chlorine release 1 electron chloride ion, and this way they will just release 1 electron sodium ion. Ion sign will be in there. Please make it with the compass, likely to have concern about that way. 2 and 8 on there. Listen, sodium ion, and also chlorine in its the outer shell electron will be the chloride ion. Chloride ion will be on there. 2 8 2 8 and 8. It is not drawing figure well. Just follow me dear to draw properly. When you will draw that one, you will try to draw properly accordingly. Sodium ion and chloride ion I have drawn in there. This diagrammatic presentation on there. What is the difference? We touch together the methane in case of hydrogen and carbon, but here it would be separate, because separate ion can bond together to form sodium chloride. You can write better to sodium chloride, then we get sodium ion plus chloride ion, whatever you got. This way the ionic compound form. C number question is gone. No, there is the polarity. I'm asking in there. Polarity. Now we will try to manage of writing the polarity of the sodium chloride. Okay. Polarity. If we explain up on there about the polarity, in case of them, I will just go through. You can get some information from there. Just a second, 1 second. I will just make you clear instruction here for make you understand about them. Okay. Sodium chloride is an ionic compound. We know about an ionic compound. Sodium chloride is an ionic compound which has positive and negative end, which have positive and negative end, positive and negative end. Okay, fine. The positive end is attracted. The positive and polarity. The headline will be here, polarity will write on there. The positive end is attracted to the negative end of water. We know about the water in have the negative end on there. I have drawn the figure on there. So positive end, sodium ion is attracted to the negative end of water, yes. And chloride ion on the other hand, chloride ion, that means negative end of sodium chloride is attracted to the positive end of water. Same thing, yes. How they will connecting with, then I say that this way sodium chloride to be dissolved in water, to be dissolved in water. That means sodium chloride in the ionic compound which have the positive end and negative end. Positive end attracted to the oxide ion, negative part of the water. On the other hand, negative end of the chlorine of the sodium chloride is attracted to the positive end of the water, and when they are attracted together, they can fix and mix together to make sure they dissolve. This is not the end. A figure is very important behind this. The figure will not in my small space. I just erase that one. You will follow me that one to write up on there. Okay. Yes, which one is the figure, how they are dissolving on there? Sodium ion positive end, where we have seen oxygen. Okay, then water molecules, hydrogen, that means water. Hydrogen is 2O, and that are the we know about. This is the partially negative charge is on there, since the positive ion in there, and partial positive charge is not attracted on there. They are distracted, plus. You will write in all case the plus. Delta plus. Water molecules have positive and negative end also, but positive end is distracted, but negative end come close to the sodium to make it dissolve. Okay, fine. At the same way, chloride ion, whatever we have seen, that times we will see hydrogen, and that way oxygen, hydrogen. In this way we can give, dear students. Someone say that, sir, many of them give the solution in different way. Why it is in different way? Dear student, look at here. I know that. I just make it mine which way the partial plus, this one the partial positive, partially positive. I have make it the explanation on there. Some case two hydrogen atom can close together to make sure partially plus, partially minus, partially plus, partially minus, partially plus, partially minus, partially plus, partially minus, are likely to have in this one. Since the chlorine in there, chlorine, so positive charge come close together by rotating and rolling anyhow, any way to make it dissolve, and since the negative charge and partial negative oxide ion will be distracted from here. This is the polarity. I think you understand. Okay, so now the question number D. We will go through the question number D. What is asking for question number D? It is to know about then. Okay, I erase up in there. Last one, last question. We don't make it lengthen. I think you understood the assignment one. D number. What is the D? Number D. Yes, it is to be told that give some explanation of electric conductivity in case of the two compound. Which way we can explain up the electrical conductivity? Okay, electrical conductivity. Explain. Very simple. This one is very simple, dear students. D number. Okay, electrical conductivity. Okay, in case of methane. I will just draw a figure accordingly here. Simple figure. Just make it a container. Since the experiment to know about, then there will be the okay. I erase that part. Positive electrode and negative electrode, anode and cathode. I think you heard the name in before. Okay, listen now. Okay, I'll make it a bulb in here. Okay, dear student, I erase that one. You can write in there. In case of methane, I need to draw a bulb like structure in there. Okay, connecting there, and here the solution. Solution. Okay, I make it sure the methane is a covalent compound. I give it in there. That means methane cannot produce on there. That means you will explain up in case of methane. How you will write? Take a solution. I tell you, take a solution. Take a solution. Methane to put in there. There, since it is covalent compound, it will not be dissolved. Other setup, two electrodes, battery, this one, and a light, connected with it, since methane not attracted to anode and cathode. Why they are not attracted? Because no charge in there, no positive charge on there to attraction anode and cathode, so light will not be on or lit up, you can write on there. So this one better of writing this one in case of methane is done on there. Simple, first one. So finally we'll write the electrical conductivity. Methane cannot ensure the electrical conductivity. So finally we'll write, last line is there on, see on my board. Yes, I can write another line. methane cannot have electrical conductivity in nature. Electrical conductivity in nature. Okay, done. Now we'll write, in case of sodium chloride, another figure you will draw in there. Sodium chloride, yes. Take a solution. What a solution? Anything. Okay, sodium chloride we will put upon there. Now it is the time to have the sodium chloride to put on there, and we will get the sodium ion and chloride ion. Battery have the two end in there. Two end. One is the positive end. One is the positive end. Okay, another one is the negative end. So positive end, it is the anode. It is the anode. Since the positive electrode, and negative end connected with the wire, we can say it is the cathode. And since the positive ion and negative ion is created in there, in case of the sodium chloride, positive ion attracted to the cathode. Since the cathode is the negative end and negative electrode, it is the positive electrode, and chloride ion attract with the positive electrode or cathode in there. Take a solution, so never put in there. Okay, since it is ionic bond, I write the same way. Ionic compound, it will be dissolved in that solution. Okay. Other setup, two electrode, battery, and a light or bulb. Bulb you can write on there. I write the light, sorry, bulb. Bulb is connected with it. Since sodium chloride have sodium ion plus chloride ion. Sodium ion and chloride ion attracted to cathode and anode, vice versa. Cathode and anode. Anode, vice versa. So light will be on or lit up. So sodium chloride can have electrical conductivity in nature. Explain up. Simple, interesting, important, and easy solution. I think you understood. So just follow me, follow the instruction, and complete your writings. Hurry up. Thank you, everyone who are connecting with me. Stay safe, stay sound. Allah.